Here I've set up a circuit that could be used as a volume control in a loudspeaker, and I'm using the bulb to represent the loudspeaker, so the brightness of the light represents the loudness of the sound. And we can see that by changing the variable resistor I can change the brightness of the light, which represents a changing volume in the sound output from the speaker. So how does this circuit work? Well, again, it's a potential divider, and the potential difference provided by the battery is connected across the full length of the resistance wire here. And then the bulb is connected between this end of the resistance wire and this contact in the middle. So as I move the contact, basically what I'm doing here is dividing the wire into two parts, or two resistors, which is the potential divider. So here I've got a small bit that side and a large bit that side. So I've got a small resistance here and a much larger resistance there. And so I've got a small potential difference there and a large potential difference there. And it's this potential difference here that is driving the current through the bulb. So the size of this potential difference here is the potential difference across the bulb. As I move it this way, I increase the length of the wire, so I increase the resistance, and so I increase the potential difference across the bulb. And so by moving this, so changing the values of the resistance this side and this side, I can change the brightness of the bulb, which again represents the loudness of the sound from the loudspeaker. Okay, so that is a potential divider, and you need to think of this as two resistors. One resistor this side of the contact and one resistor this side of the contact. And all we're doing by moving this is changing the size of those two resistors in your potential divider. The circuit for the potential divider will look like this. Here are the two batteries, and they are connected across the resistance wire, and then there's the bulb, and there's the sliding contact. So this bit here, I've got this resistor here and this resistor here, and by moving the contact I'm changing the size of the two resistors in my potential divider, where the potential difference provided by the batteries is shared between these two parts of the resistor, and I'm just tapping off the bit of the potential difference that I need for my light bulb. As I move this way, there'll be a bigger potential difference across the light bulb, so it'll get brighter. Here I'm using a potential divider as a balancing control in a circuit. Usually it's used with two loudspeakers to balance the amount of sound coming out of each speaker, but because you can't see sound on a video, I'm using two light bulbs to represent the two speakers, and the brightness of the bulb represents the loudness of the sound coming from the speaker. So I can adjust the bulbs or speakers by changing the variable resistor here, the potential divider. So how does it work? Well, the batteries here are connected to this long resistance wire here that runs all the way along, and also these two bulbs are connected in parallel with that. So I've got the resistance wire and the bulbs in parallel, and then connected between those two branches from the middle in between the two bulbs to this contact that runs along the resistance wire I've got another connection here, so that as I move this way, there's more of the resistance wire on this side, so there's a bigger voltage there than there is there, so I've got a bigger voltage across that bulb than I have that bulb, so that one's brighter than that one. If I move it the other way, then now I've got a longer bit of wire there, so I've got a bigger resistance there, so I've got a bigger voltage across that bit than I have across that little bit, so that means that I've got a bigger voltage across that bit and that bulb than I have across that bulb. And so using a potential divider you can control the balance of the brightness of these two bulbs, and it would work just the same in a balance control on loudspeakers. Okay, here's the circuit diagram for the balancing circuit. I've got the two batteries and they're connected across the resistance wire of the rheostat. And then in parallel with that I've got the two bulbs. Now if the circuit was like that, then the potential difference across the two bulbs would always be the potential difference across the provided by the batteries, and so each bulb would be equally bright. But to make this into a balancing circuit, I'm going to take a connection here to the sliding contact on the rheostat. Now this is a potential divider where I've got one resistor here and another resistor here, and the potential difference provided by the battery is shared between these two resistors, and that's now able to change the potential difference across each of these bulbs here. So as I move this way, so this gets bigger, so the potential difference across this one gets bigger and that gets brighter, and the potential difference across this one gets smaller and that one gets dimmer. Similarly, if I move this back the other way over here, then that means that resistor gets smaller, so the potential difference across that part of the resistor is smaller, so that makes the potential difference here smaller, and so the bulb is less bright. So that's a balancing circuit.